Okay, in this section, we're going to talk about multiple angle identities, and there are two. One is the double angle identity, and the other is half angle identity. So, what does this mean by double angle? Um, okay, so double angle, let's just kind of start with one of them. So, for example, sine, let's call it just x. So, sine 2x. Sine 2x is the same as saying two x's together. So, basically, sine of something like x and x, right? X plus x is 2x. So let's derive the formula ourselves by using, you see how this is a plus and plus, so let's just use a sum and difference formula since we already memorized that. So we know that the sine formula, remember, is sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. So this is sine, cosine, cosine, sine. So sine, cosine, plus, because the original formula is plus, cosine, sine. Now you can see that sine, cosine, and then cosine, sine, because the angle inside, they were all x's. So essentially, I can switch these two, and then I would have two of the same thing added together. So essentially, what I can do is rewrite this as 2 sine x cosine x. And this is the formula for double angle for sine. Okay, we can do the same thing for cosine. So cosine double angle. Okay, so double angle, two angles or two of the same angle is the same as x plus x. So we can try to derive the formula the same way. So cosine, cosine, sine, sine, sine. Okay, cosine, cosine, sine, sine, sine. Okay, so cosine, cosine, that's going to be cosine squared because the angles are the same, minus sine squared. Good. So this is one of the cosine double angle, and the one of them because we can start from here and derive the other two. So there are two more. The other one is if you were to change, let's say, cosine squared. So kind of remember the first section where we were doing a lot of identities and proofs. So cosine squared, so remember sine squared plus cosine squared is 1. So then if I just want cosine squared, I can just subtract sine x on both sides and then say cosine squared is the same as 1 minus sine squared. So if I were to do that, I would replace this cosine squared with 1 minus sine squared. And then this part remains. So then this is 1 minus 2 sine squared. All right, this is my second formula or second version of the same formula. Let's say that I want to, instead of changing cosine squared, I wanted to change sine squared instead. I can derive my third formula. Okay, so I'm going to start from cosine squared minus sine squared. Okay, instead of changing cosine squared, I'm going to change sine squared. So how do I do that? Same thing from here, starting from here. I can say that sine squared is equal to 1 minus cosine squared. Okay, if I do that, I'm going to substitute that right in here. So cosine squared minus 1 plus cosine squared. You can see that here I have two cosine squares, so I can rewrite it as 2 cosine squares minus 1. Okay, so this is all the same. Okay, so this is my third formula. So 1, 2, 3. All three of them mean the same thing, and you can use any of them for cosine 2x. The last one is the same kind of idea, but we're not going to go through the derivation of it. I'm just going to give you the formula. So tangent 2x is equal to 2 tangent x over 1 minus tangent x. All right, so these are my double angle formulas. I'm going to do the half angle formulas. So here, half angle formulas, but these, um, we don't have a lot of time to derive them, so I'm just going to give you the formulas. So sine x over 2, so half of the angle, this is equal to plus minus square root of 1 minus cosine x over 2. And then cosine x over 2 is equal to plus minus square root of 1 plus cosine x over 2. So these two formulas are very similar, except for the plus sign. Tangent x over 2, there are three formulas that you can use. First one is plus minus square root of 1 minus cosine x over 1 plus cosine x. Plus minus doesn't mean you have two answers for, these. You can see that they're plus minus, and plus minus. Plus minus doesn't mean there are two answers. Plus minus means you choose one based on wherever that quadrant is. So, when we solve things, I'll kind of show you how to choose. Okay, and the other one is 1 minus cosine x over sine x. And then the last one is sine x over 1 plus cosine x. All right, so we're going to spend a lot of time we're going to spend a lot of time learning how to solve equations that contain these half angle or double angle formulas. For example, this one. Sine square x equals 2 sine square x over 2. All right, the most important thing is the variable, and I put variable in quotation because it's kind they're not always kind of like variables as in, oh, we're using x's. What I'm trying to say is this part that they're like whatever is inside sine or whatever is inside a trig function, they have to be the same kind. So you can see here, this one is x, this one is x over 2. They're not the same kind, so I actually cannot solve it. So what we have to do is we need to change them so that they're exactly the same. Well, how do I do that? Either I can change this x in this sine square x, that there's some kind of formula that helps me change this x part into x over 2, or there's some kind of formula that has x over 2 that can change back into x, which this way around, I don't know of any formula that does that, but I do know formula that changes x over 2 into x, and that is the half angle identity. So for example, you can see here, this sine x over 2 is equal to this formula that just has an x inside the trig function, not an x over 2. So if I substitute that in here, I can solve the problem. All right, so how do I do that? Let's do this. So on the left-hand side, I'm not changing anything. On the right-hand side, I'm saying that sine x over 2 is this formula. So this formula is going to replace sine x over 2. But there's a square here. So kind of recall sine squared x over 2. So let me rewrite this. Sine squared x over 2 is the same idea as sine x over 2 squared. So when they put the square here, it actually just means the whole thing squared. It's just a shorthand for writing that. Okay, so this is really just saying, okay, you're going to take sine x over 2 and square that. Well, what is sine over x over 2? That's this thing. So we're going to take that thing, and then we're going to square it. All right, rewrite. Well, if you square something that is a square root, you just basically take the square root off. So this becomes this. All right, I can see that the 2's are going to cancel. So sine squared equals 1 minus cosine x. And I need to solve that. Well, anytime I have a square something, most of the time we're going to make it equal to 0 and try to solve that. So minus 1 plus cosine x equals 0. I don't know how to solve this, especially because this one's in sine, this one's in cosine. So it would help if I were to turn everything into cosine. So I'm going to do that. Sine squared is equal to 1 minus cosine squared. And then I keep the rest of these. Ones are going to cancel. Minus cosine squared plus cosine equals 0. And then I can see that cosine is repeating, so I'm going to factor out cosine. So negative cosine plus 1 equals 0. All right, that's good. We're in factor form. I'm sorry, I put a squared in. Okay, so that means this is equal to 0, or this is equal to 0. Okay, so that's 1 equal to cosine. All right, so now think about the angles that will make this work. What angles make cosine 0? That is pi over 2, 3 pi over 2. And then plus 2 pi n plus 2 pi n. All right, what angles make cosine 1? That is 0 only, so plus 2 pi n. N is an integer. All right, so let's go ahead and try another one. This one says solve algebraically, but only within the interval 0 to 2 pi. Okay, it says sine 2x equals cosine x. All right, so again, this one has a 2x, this one has an x, we cannot solve it. So what we want to do is use something to change them to the same variable, which in this case, I would probably say change both of them to x. That means this sine 2x has to go. Well, sine 2x is the double angle formula, so we just need to look up the double angle formula for sine, which is 2 sine cosine. And that's equal to cosine x. So what we're going to do now is set it equal to 0. And then I can see that cosine is repeating, so I'm going to factor out the cosine. And then set each part equal to 0. Okay, and then that means sine x is equal to 1/2. All right, again, so now you want to think about what angles would make this work. So same thing as before, cosine equal to 0. That is at pi over 2 and 3 pi over 2. This time we don't add 2 pi n because it says just find it within that one unit circle. Sine x equals to 1/2, so x is equal to pi over 6 and 5 pi over 6. So that's it for answers. Okay, let's have you pause the video and give this one a try. Cosine 2x equals cosine x. So again, this is going to make you use the double angle formula, but double angle formula, there are several double angle formula for cosine, so you're going to have to choose one. You know, it really doesn't matter which one you choose. You can get to the same answer, but sometimes one formula is a little better than the other, so kind of choose wisely. As in, you want to look at the formula and see which one would get you to the answer faster. Okay, so go ahead and pause the video and come back and check your answer. All right, go ahead and check your answer. So you can see here that when I chose the formula, I chose the one that has only cosine because I'm seeing that on the right hand side as a cosine. So that would help me get to my answer faster. So I got to this part and then I factored it, set each part equal to 0, and then these are the answers. All right, let's try this one. This one, you have a double angle here, and then you have 4 times of the angle. So what should you do when you have 4 times the amount of angles? Well, there are a few things you can do. For example, you can think of cosine 4x as in the 4x, you can think of it as 2 times 2x, right? So double of the double angle. So two, or you can just say, oh, it's 2 times of this angle 2x. Or the other way you can think about it is it's really just 2x plus 2x. Okay, either way, they can't get you to the answer. Now the question is, do I need to change this part to a double angle formula? Well, my suggestion is that you don't, because what you would do is you can see that this is a 2x, and if I use the double angle formula on here, I will get to 2x, or if I use the sum and difference formula, I would get to 2x. So what I'm saying is, when I can get all the variables to be the same, in this case, they're all 2x, I can solve the problem, right? In the previous problems, what the reason I was doing all this formula substitution is that um, the the problems had variable that were different. So, one part I was an x, the other part was an x over 2, or one part was an x and the other one was a 2x. But in this case, one part is a 2x, the other is a 4x. If I can get both of them to become 2x, there's no need to go one more step and get them all down to x. I can just solve from 2x. So that's what I'm going to do. Um, so, I don't know if any formula is really faster than any other. So since we're in the section of multiple angle identities, we're going to use double angle formula. So I'm going to rewrite this problem. So cosine 2x plus cosine 2 times 2x. 2 times 2x is the double angle formula for cosine. So I'm going to choose one of them. Since this problem already has a cosine, I'm going to stick with cosine. So 2 cosine squared. And then this part is the part that goes into the formula. So 2x. And then minus 1 equals 0. All right, don't make this too hard. It's really just saying this is the variable. So we have 2 cosine squared and then cosine, and then minus 1. Okay, I'm going to rewrite this so it might be a little easier to see where we're going next. So 2 cosine squared 2x plus cosine 2x minus 1 equals 0. So basically, if you want to do a substitution, this is really, if I said, let's say a is equal to cosine 2x. If I just said that, then I would say this equation becomes 2a squared plus a minus 1 equals 0. And that's just a factoring problem that you can do. So if you want to do that, you can. I'm going to skip this part and then just stick with cosine. All right, so let's factor this. 2 cosine 2x. And then this part is cosine 2x. Oops. Plus 1 minus 1 equals 0. Okay, so 2 cosine 2x minus 1 equals 0. Cosine 2x plus 1 equals 0. Okay, so solving the left-hand side, cosine 2x equals 1/2. On the right-hand side, cosine 2x equals minus 1. All right, let's solve this. What angle makes cosine 1/2? That is pi over 3 and 5 pi over 3 plus 2 pi n, right? Well, what did we solve for? Did we solve the angle for x, or did we solve the angle for 2x? We solved the angle for 2x. Why is that? If you look at the question, cosine of what angle equals 1/2, right? Cosine of what angle? Well, we said, oh, that angle is pi over 3. Well, pi over 3 is what? The angle being 2x. So then 2x is pi over 3. So we didn't finish solving for x yet. So be careful when the variable is not just an x. You have to take into account that you have to do one more step to solve for x. And then you have to add this 2 pi n, because when you solve for x, you're going to divide by 2, which means everything divides by 2. And that includes this part. So if you didn't have that part, you would be missing some angle. So be careful of that. Same thing here, 2x is equal to that. And then if I wanted to solve for x, I have to divide by 2. All right, so what does that mean? All right, so the first one, rewrite. So x is equal to pi over 3 over 2 is pi over 6 2 pi n divided by 2 is pi n. Okay, and then the second one, 5 pi over 3 over 2 is 5 pi over 6, and then plus pi n. So what does that mean? That means pi over 6 plus the first pi would be 7 pi over 6. So 7 pi over 6 is also one of the answers. If you did it another way where you just started from, you went all the way down to x instead of 2x, you would get the same answer as well. All right, let's try this part. Cosine something equals -1. So then what is that something? Well, that angle has to be pi, and then plus 2 pi n. All right, and then we're solving for x, so we have to divide by 2. So then that means x is equal to pi over 2 plus pi. All right, and oops, n is an integer. So these are the answers. All right, let's try the last question. Find the exact solution. And this one has tangent. Okay, so it's tangent half angle. You can see that the variable is x over 2, while the other ones are all x's. So we're going to change it. This one, I'm looking at the tangent half angle formulas. You can see that there are 3. And since this part looks the most similar to the first formula, I'm going to just say it's probably going to be the first formula that I'm going to that this question wants me to use. So I'm going to use this one. You can see that this is very similar. So let's try to figure out what we're going to do next. I'm probably going to square this just to get rid of the square root. So 1 minus cosine x over 1 plus cosine x is equal to, please remember not to square each term. That's not a property we can use. All right, we get to this point. I'm guessing we need to cross multiply. So 1 minus cosine x times 1 plus cosine x squared equals 1 plus cosine x times 1 minus cosine x squared. All right, at this time, I'm very tempted to cancel out some factors, but I know that if I do that, I might cancel out some answers. So what I'm going to do is I'm going to show you this trick of doing some factoring that you haven't seen before. We're going to make this equal to 0, so I'm going to move everything to the left-hand side. Okay, now I'm going to look for the greatest common factor between the two. The two meaning first term, second term, because they're all separated by a big minus sign. So I'm looking for the things that are the same between them, which you can see is very apparent. There's 1 minus cosine. There are 2 here. There's 1 plus cosine, and then there is 1 here. So basically, they all share 1 of each. So what I'm going to do is I'm going to factor out 1 of each. So if I take out 1 of each, so I'm going to take out 1 minus cosine, and I'm going to take out 1 plus cosine. Then in this term, if I take out 1 minus cosine and 1 of the 1 plus cosine, then what I have left here is just 1 plus cosine left. Okay, I'm going to do the same thing in the second term. So if I take out 1 minus cosine, and 1 plus cosine, then I have another 1 minus cosine left. Oops, that's a minus there. So I have to keep the minus from here, and then this is the factor that's left. All right, so rewrite this part, 1 minus cosine x, 1 plus cosine x, and I'm going to clean this up. You can see that this is gonna, if I distribute a negative sign, I get 1 plus cosine x minus 1 plus cosine x. So the ones are going to cancel. I have 2 cosine x. All right, each part equals to 0. So 1 minus cosine x equals 0. 1 plus cosine x equals 0. 2 cosine x equals 0. So cosine equals 1, cosine equals -1, and then cosine equals 0. All right, that's when x is 0. This is what? Only within 0 to 2 pi. So 0, this is pi, this is pi over 2, and 3 pi over 2.